Hello and welcome to the video lecture course brought to you by St. Andrews Institute of Technology and Management. We are discussing the subject Programming for Problem Solving, that is PPS. And today we are going to discuss about a special type of operators called unary operators. Now we have seen the operators in C, that is your addition, summation, your multiplication, your integer division and all that. And today we're going to see a special kind of operators with some special meaning called unary operators. But before that, let's see one example of all those operators that we have seen in their last lectures. Okay, we haven't implemented any of those operators yet. So let's get back to the IDE and try to implement one. So let's say we want to have the average of three, let's say, numbers. So in that case, I will first declare three integer variables called int a, comma b, comma c, and I will ask the user for its values. So would be scanf, your standard input function that has been defined in the library called stdio.h. Okay, and then when we talked about in the first lecture, I've told you that this is your standard input function scanf, and it means that it is asking the user to input the value of a. So whatever you are going to type from your keyboard will actually be assigned to the address to which a is pointing. Now this means address. This ampersand is actually pointing to address. Okay. So the memory reserved for variable a will be assigned to the value which you have inputted through your keyboard. So keep that thing in mind. Next one is sorry. So I'll ask all the three values from the user itself. Okay. Now I have to find, let's say, average of these three numbers. For that, let me define one more. So float, let's say result. And now what we'll do is float will be assigned, and we'll try to write an expression here. We have seen expression in our last lecture. So we'll add the three numbers a, b, c, a plus b plus c. And I will divide it with 3. This is how you calculate the average, I think. Then I will try to print it out, the result. So I can write the result is percentage, not percentage d for float, you have to write percentage f, and result. Okay, so let's save this and try to run it. Let's see if it gets through. Okay. Oh yes, sorry, not float. Yes. Let's do this again. So it is blinking there, so it requires the numbers. So let's do 1, 2, 3, 4. So the result is 3.0. So 3 plus 4 is actually 7, and plus 2 9, and 9 divided by 3 is actually 3. So our result is all right, I think. So this is just one example which implements the expression that we are talking about in our last lecture. See, we have this expression here in this line. Okay, the rule says that this operator has the highest precedence in all this complete expression, but as you can see that we have implemented these brackets, and brackets actually supersedes the division operator. So first of all, the brackets will be solved. That means a and b plus b plus c will be solved, and the answer then will be divided by 3. So this is what we have seen in the last lecture, the order of precedence of the operators. We will be using these, let's say, these operators time and again. In the next unit, we will be going to implement one example in each lecture at least. So we'll have quite a uh, quite a large amount of practice in the coming lectures, because theoretically we are out of let's say topics now. We are out of topics. All we have to do is now let's head back to the unit 2, and that is where the actual implementation of all these knowledge that we have gathered in lecture in unit 1 is going to be implemented. So let's get back to the unary operator that we are talking about. So we have two unary operators with us uh, in our C, that is plus plus and minus minus. Now why they are called unary operators? They are called unary operators because they are applied on single operators. They are applied on single operators. Okay, you must have seen A plus B until now, or you must have seen A minus B until now. Now, these operators of summation and the difference between the two numbers is actually implemented on uh, two operands. Two operands, okay? So one operand is variable A, and second operand is variable B, whatever the value they have. And in this case also, we have one operand that is variable A, and another one is variable B. So writing like this doesn't make any sense, because A minus what? We have nothing there. So this expression is not a valid expression. Okay. Likewise, removing this like will make no sense, because something must be added to B. That's why this operator has been implemented there, has been there actually. So this makes no sense. But in case of unary operators, all this will make sense. Okay, this will make sense, as well as this will make sense. Okay. Please pardon the Microsoft word there. And this will also make sense. Similarly, this will also make sense. So these unary operators are actually applied to single operands only. And what it means is, all it means is increment by 1. And it means is decrement by 1. Okay, so this is what your plus plus operator or minus minus operator, as you will call it. Yeah, okay. We'll see that in a minute with the application of these two numbers, but they comes very handy while using the loops. We'll be going to use the loops in next unit, and they will come in handy. So unary operators are just addition or deletion of one to the operands on which they are working on, nothing else. Okay, nothing else. But their placement is of utmost importance. Okay, their placement is of utmost importance. So what I am saying here is there are two type of unary operators. First is prefix, and next one is postfix. Now prefix means before the operand, like in this case we have applied the unary operator before the operand itself, and postfix means after the operand, like in this case we have applied the decrement unary operator after the operand C. Now both of them will result in same answer, but what they are going to return is of difference. What they are going to return is of difference. So I will not show anything here. I will show you in the code itself what I am trying to say. So let's remove all this first, and we are going to use this post and pre-increment operators. Okay, so let's say we have int a equal to 10. First, let's try to print the value of this. So, so a is equal to percentage d and a. Now, first I will try to insert the prefix unary operator or the preincrement. So printf, and I will say plus plus a is equal to percentage t comma plus plus a. So say we have applied the preincrement unary operator. Okay. Next, I will try to print the value of a again. Okay. So let's say what is happening here. Let's save it and let's move on. Okay, what is happening? Time to okay, I haven't planned this. Okay, done. Oops. Wait a minute. This will be solved in a second. Not to worry, we have to apply an escape sequence. Now backslash n implies new line. Okay, we have talked about this in the last lecture. Okay, now a has a value of 10. After the application of unary operator, as I've told you, it will increment the value of operand by 1. So 10 plus 1 is now 11. And again, if I try to print the value of a, the value has now become already 11. It has been incremented by 1. So this is common actually. This is not of something very significant, but it will now. Now I will try to do this by post incrementing it. That is, first in the new line, I will try post incrementing it this time. Okay, so now let's do it again and see the difference. Okay, here it is. Let me show you what is happening actually. And let me align this. Yeah, okay. Now from the first line, we have just printed the value of a, which is actually 10. So it is done here in this line. In next, we have printed the preincrement unary operation on a. That is, increment the value of a by 1. So the value of a becomes 11. In the next line, I have just tried to print the new value of a, which has already been incremented by 1. Sorry, which has already been incremented by 1. So it has been printed here as 11. Next, I have tried to post increment the value of a. And this time, it doesn't get incremented. The value is still 11. But in the next line, when I try to print the value of a, it gets incremented by 1. So what is happening here? The thing is, when you try to implement the prefix unary operator, like in this case, see, let's go to this line first. In this line, when you try to implement this printf function, the argument you have passed here is a. So the value of a which has been passed here is 10, nothing special. And 10 is printed ahead of this assignment operator in your console, like this, like in the first line, nothing special. In this case, in the second case, the value of a, in this case, the value of a that has been passed to the printf, by passing means I have given the value of a to the printf. Because of this pre-incrementation, that is, the unary operators are prefixed, that is, are ahead of the operand. First, the value of a will be incremented and then it will be passed. Let me say that again. First, the value of a will be incremented and then it will be passed to the printf. So printf will receive value 11 instead of 10. Again, in the next line, when I try to print the value of a, it has already been incremented by 1 in the last line itself, that is 11. So it has printed 11. Now in this line, actually this unary operation is actually post increment. In post increment, the value of a will be passed as it is, and after passing or after returning the value of a, it will be incremented by 1. So what is happening here is, first the value of a will be passed to the printf function without incrementing, and when the compiler will switch from this line to the next line, that is after this semicolon, at this junction the value of a will be incremented by 1. So this will increment the value before passing on to printf, and in this case the value of a will be incremented after the value has already been passed to the printf. So you have got the understanding that why 11 has been printed here. 11 has been printed here because the incrementation takes place, or the increment by 1 takes place at this junction, as the junction of this semicolon, when the value has already been passed to the printf. So that is why the printf received the value only 11. But after this semicolon, that is when the compiler heads to the next line, it will first increment the value of a by 1. So that is why in the next line, when I try to print the value of a, it is actually 12 and not 11. So there is a difference in the implementation of the prefix and postfix operators. You must be careful how you want to print the value. Okay, in pre-increment, incrementation will take place first, then the value will be passed. In post increment, value will be passed first, and then the increment by 1 will take place. So you must be very careful how you are going to deal with it. Okay. So, and similarly with the case with your decrement operators, let's just use decrement operators this time. We haven't used them yet. So let's save it and run them. And let me make one more change. I haven't changed it. This and okay. Okay, the value of a is 10 at the beginning. Value of a is 10 at the beginning, has been signified by wait yeah. So in the first printf statement, the value of a will be printed, which is actually 10. Then the pre-decrement operator has been applied, that is the value of a will be decremented first and then it will be passed on to printf. So the value that has been received by the printf is actually 9 or not 10. Okay, so it has printed 9. Now in the next line we have printed again the value of a, which has already been decremented by 1 in the last statement, so its value will again print 9. And then in the next line I have tried to print the value of a with post decrement operator, and in this case the value of a as it is will be passed first, and after the passing on to the printf the decrement will happen. So the printf will receive the value of a as 9 and it will print the 9, and after, when we head on to the next line, the next statement, the value of a will be decremented eventually. So the value of a which has been received by the printf in the last line is actually 8 and not 9, because it has been decremented as we have moved from this semicolon, as compiler have moved from this semicolon. So the pre-decrement and post-decrement also work same as pre-increment and post-increment and pre-increment, that is, it will decrease the value by 1. But when it is going to decrease depends on the prefix and post fixation of the unary operators. So I think we are done with the operators now. In the next lecture we are going to start with the conditional operators, and then we'll see a few of the examples, some typical examples that we haven't seen until yet. Thank you.